Hello students. In this video, we will learn about the amazing world of gravitation. This powerful force shapes our universe, making the planets move and keeping us anchored to the Earth. First, let's talk about the universal law of gravitation, formulated by Sir Isaac Newton. This law explains how objects with mass interact due to gravity. Essentially, every object in the universe attracts every other object. The gravitational force between objects depends on two key factors: the masses of the objects and the distance between them. The more massive the objects, the stronger the gravitational pull. Conversely, the farther apart they are, the weaker the force. We can express this force mathematically with the formula F is equal to G into M by R square. Here, F represents the gravitational force, G is the gravitational constant, M and M are the masses of the objects, and R is the distance between their centers. This law also introduces a couple of important ideas. First, there's the inverse square law. This means that as objects move further apart, the force of gravity becomes weaker. For example, if you double the distance between two objects, the gravitational force drops to 1/4 of its original strength. Additionally, if the mass of an object increases, the gravitational force increases as well. Another interesting point is that gravitational force has both magnitude and direction. It always pulls objects toward each other. And if object A pulls on object B pulls on object A with the same force. This is called the principle of symmetry. Gravity has some key characteristics. It's always attractive, meaning it pulls objects toward each other. For example, when you drop a ball, it falls to the ground because of Earth's gravity. Gravity works through empty space and through other materials like air or water. The work done against gravity doesn't depend on the path taken. The gravitational force acts along the line between two objects' centers. Now, let's talk about the gravitational constant G. It's a small number, approximately 6.67 into 10, minus 11 Newton meter square by kg square, which is why gravity doesn't seem strong on small objects unless they are very massive. Objects falling towards Earth experience acceleration due to gravity denoted as g, which is about 9.8 meter per second square near the Earth's surface. This value can change depending on where you are, whether you're at the poles or the equator. It also varies with altitude and depth inside the Earth. The spinning of the Earth affects gravity slightly too. The relationship between the acceleration due to gravity, g, and the gravitational constant, g, involves the Earth's mass, m, and radius, r. For objects moving under gravity, we use equations to describe their motion, whether they're falling or moving upward. Now, let's differentiate between mass and weight. Mass is the amount of matter in an object and stays the same everywhere, measured in kilograms, kg. Weight, on the other hand, depends on gravity's pull and can change based on location. It's measured in newtons, N, and calculated with the formula W equal to M into G. On the Moon, gravity is weaker, about 1/6 of Earth's gravity. So, an object will weigh less on the Moon than on Earth. You can use the same weight formula, but with the Moon's gravity for calculations. Lastly, let's explore Kepler's laws of planetary motion. Kepler's first law tells us that planets move in elliptical orbits with the Sun at one focus. The second law says that planets travel faster when closer to the Sun and slower when farther away, keeping the area swept out by the planet constant. The third law connects the time it takes for a planet to orbit the Sun with its distance from the Sun. The further the planet, the longer it takes to complete an orbit. Now here is a question for you. According to the inverse square law, if the distance between two objects is doubled, how does the gravitational force change? Please share your answer in the comments. The complete curriculum for Class 9 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.